I think the way to sum up what really sets the mood and what drives everything is John Matthews. When I originally went to him and set up this suppressor thing, the only guidance he gave me, he said, build the best. That was it. And that is always our goal.
Hey guys, Tyler here from Silencer Shop, and this week we've cooked up something a little extra special for you guys. We are flown out to SureFire here in California, and we're going to be taking a little behind the scenes, never before seen, how it's made kind of look at SureFire silencers and what really sets them apart as a manufacturer of silencers. I know most of you know them from their flashlights, but oh hey, what's going on?
I'm sorry to interrupt.
No, you're fine.
Is this SureFire?
It is, yeah, right there, that building right there. Just a little bit of a look at, again, SureFire and what sets them apart as a manufacturer and why their flashlights and suppressor division are housed here in California.
The objective for a finished product, usually most of our military products, those objectives have been defined by the customer. You know, the initial suppressor we were competing with, SOCOM said, hey, we really love it to be 17 ounces, but it can be 24 ounces because that's what we're issuing right now. So I looked at it, I was like, okay, I want to make this thing strong, I want to make it lightweight. Let me look at the materials used inside of jet engines. So that's where Inconel came up. People put Inconel in the blast baffle. Maybe they put Inconel in all their baffles, but all their spacers and their outer tube are stainless. If you're trying to make a lightweight suppressor, the only way to make a lightweight suppressor extremely durable is better materials. When stainless steel gets hot, it loses all its strength. Inconel retains it. Yeah, and there's a lot of different high temp alloys. Inconel happens to be one of them, but I was able to increase strength, increase durability, and at the same time decrease weight, so the operator had a lighter package on the front of his rifle.
What we're doing here is all of the parts are pressed or from the machining, and they got a lot of oil on them and stuff. So with our welding process, cleanliness is next to godliness.
Right.
So this machine right here, we're coming in and we've had a chemistry, detergent, the chemistry on there has been designed from some scientists to remove all of the oils. We come in here, we'll clean it with hot water, soap it, rinse it, ultrasonic it, and then dry it. And then those parts are actually, everybody's wearing gloves.
So it's a fancy dishwasher. A very fancy dishwasher.
A little more than a fancy dishwasher.
Got it.
But everybody's wearing gloves, so once the parts come out of here.
And so these come from Turning Center or coating or wherever they come from?
Yeah, Turning Center, or we have them stamped and stuff like that for the baffles.
So from a raw part that's been machined, comes in here first.
Correct.
This is the first stage in this building. It comes in here, gets cleaned.
Correct.
Ready for welding or wherever it goes from here. So what gets cleaned, and does anything not get cleaned? Like muzzle devices? Everything gets cleaned?
Everything gets cleaned.
Okay.
Everything comes in, goes through there.
Got it. And it doesn't care about material, so Inconel, aluminum.
For the parts, for the suppressors, it doesn't care.
Right.
It's the parts, let me say this a different way. The parts that are machined with the oils that it's designed to clean, it doesn't care.
Got it.
So we can put anything in there with the machining oil.
Got it.
Different type of oil, we have to have a different chemistry.
Cool. A lot of the reason for this is the laser welding. So parts have to be, you know, perfectly clean, or you have a chance that you can get a bad weld.
Initially, when came in, we were looking at the processes. We had manual weld processes. We could put out so many a day. We did final inspection, but as we grew and went into laser welding, we changed into the technologies. We had to have process improvements in place. Even changing the technologies, the quality of our parts coming from the Turning Center had to improve so that we could actually use them and meet the goals that we were doing. We implemented electronic data collection system, so to speak, electronic router. So every operation, the operator scans his badge, the serial number he's working on, the tool he's using, the machine he's using, and then the start and the stop and the quantity.
You know, for control purposes and also just, you know, controllability with suppressor parts, we do all of our heat treating in-house. So, you know, this is, you know, going to come out tomorrow.
Got it. So that's a process.
You know, back here, what we try to do is maintain a buffer inventory of parts. So if a military unit calls up and says, we got an emergency, we need whatever suppressor it is,
X number of,
we can transition the line over, get it into production. So we don't want 10 years worth of parts sitting on the shelf.
right?
You know, stuff gets obsolete, things go bad, there's other reasons, but we want enough parts that we can transition rapidly if needed.
That was a theme, I think, at the Turning Center as well. The raw materials, keeping a rolling inventory, but not so much that you've got stuff sitting around that you're never going to use.
Yeah.
Yeah.
And that's where Dennis really sharpens his pencil, and, you know, he used to, you know, be a master scheduler for the B1B.
And so parts that are stored here, kind of ready to go, at what stage are they stored? I mean, are they ready to go to the welder and get welded together?
Yeah.
Are they already welded together? You got baffle stacks sitting back there, or individual parts and pieces that are just ready to be assembled?
Individual parts and pieces ready to be assembled, and, you know, whether they need to go through heat treat, it depends on how long the heat treat process is.
Right.
We have machines here from 6-axis up to 18-axis machines. All machines are capable of finish the part in one operation. Raw material goes in on one side of the machine, the finished part comes out another end. The finished part will be picked up from a counter spindle with a gantry or robots, so they don't get damaged in the process. The 6-axis machine is more for simpler parts, and then if you go up to 18-axis, this would be more for our complex parts.
We've tried to automate deburr wherever possible because we want the parts to be the same from the first to the last.
Sure.
So if you get, you know, 10 people deburring by hand, you're going to get 10 different
on every single time they do it. Right.
So that's where these machines have a little Ferris wheel.
Back up on me a little bit too and explain, what is deburring? So part comes off a machine.
Part comes off a machine. There's sharp edges on it. Could be burrs. So in the case of like threads, if you have a burr on a thread, it could seize up when you go to put it on the weapon. Things
little
like
imperfections
that.
or leftovers from the machining process.
It's leftovers, not really imperfections.
Right.
It's just it's you know,
sharp edges and stuff left
Yeah,
over.
it's not really practical to do them on the machine to that level, so they'll go into here, and these are automated, so we got different programs running this machine, different media, or we could take, like in this case, you can have like one set of media, and you put a scoop of abrasive in with it, and that gives you a completely different level of deburring for the same run. And this can do, you know, fine thread aluminum parts for like a Ryder 22, and it can also deburr, you know, Inconel and stainless.
Right. I mean, he's got a stack of SOCOM lock rings there.
Yeah.
Getting it ready.
The capability of the machines, we are able to do everything in one setup. This gives you a lot higher accuracy. It allows you to do more intricate parts. It makes it a lot more efficient. The capability with what we have. I had the support right away from the beginning when I started here from an owner of SureFire. We had to spend a lot of money here. We have a lot of money sitting here on the shop floor. This was also very interesting for me to have the backup from an owner of the company to be able to do this what I wanted to do. To have this kind of machines. I don't want any second operation. I'm a freak of speed. I want it done fast, very accurate, and I don't want to settle for second place when it comes to machining.
Actually lining that up on the edge of the weld. So this weld will actually get on both sides of a baffle. Even if that baffle is 20 thousandths thick, it's going to get a weld on both sides of it.
That's incredible.
This is putting a laser weld on every edge of the baffle. So he'll go through and line up the crosshairs where the weld needs to be. He hits go, and this machine right now is putting on a surgically precise weld that's significantly stronger than a normal manual weld would be on the same part. And it minimizes the amount of heat going in, so there's less distortion, and most of all, it's consistency.
Right.
When you have manual welders, it's the artistry of the guy doing it, so you got to really search to find people that can weld that well.
And don't sneeze halfway through it or something.
Yeah.
And so this machine, is it programmed? It knows where every baffle height is? Or does he go in there and manually set the height?
It depends. We have some different machines, so it'll automatically go to where the weld's supposed to be, but there's a tolerance on parts.
Right.
So let's say normal machining tolerance is ±5. So there's slight offset. So he'll check where it stops, and then reposition.
Put his crosshairs on it.
Reposition the laser.
Right. And so parts came in here. They got washed, they got cleaned. If they needed heat treat, they went to heat treat, deburred, and then baffles get stacked up and ready for this machine. They get set in this machine, spun around and welded.
When it comes off, each one of these seams is its own individual weld.
Right.
And so what that's doing, we got great consistency, great quality control, part to part, and extreme amounts of strength. So there's RFID job travelers that go with everything, because each person who was running the machine, which welder it was on, all that information is traveling with this, and it goes from basically like these iPads, around the shop to get it ready to go.
And so how is that individual part tracked? There's obviously not a serial number engraved on it yet. Do you have like an internal?
There's actually a serial number assigned to it before we ever started working on it.
It's not actually engraved on there, but that tag has that serial number that it'll eventually get engraved with.
It will.
And that's how you're tracking that individual
That's how we're tracking it. And even down to the lot number of the baffles that went through, the heat treat of the baffles, the material that went in to make those baffles, that's all tracked and traceable.
The RFID tags are issued initially. We create a job for, let's say, 100 suppressors. We'll get 100 serial numbers, and each serial number is an RFID. So we'll get the RFID tag with this serial number, and we put them on a strip. When we issue the jobs to the floor, at the first operation, click it all the way through. So we track that serial number all the way through test fire into the vault to shipping. So every step of the way, that RFID is being tracked in every process.
Coming back in, the fact that we can hang on to this now.
I was just about to ask if he was crazy for picking that up.
No, if you manually welded this, there's no way.
Right.
But if you notice that there's not even heat discoloration in the parts.
So the machine is giving you that repeatability and removing the human error from the equation entirely.
That's exactly what it's doing.
That's awesome.
The attachment areas are a couple different types of stainless, and the very front exit of the suppressor, that used to be made of Inconel back when we were a stamp design. When we went to a more intricate machine design, we ended up going to a stainless on the very exit baffle. Some people call it a front plate, some people call it an end cap. And the reason for that is just economy of cost. So even the military doesn't want to pay more for something if they're not getting anything for their money. And by the time the gases get up to the front of the suppressor, they're slow enough and low enough pressure. There wasn't any gain. I couldn't make it lighter or more durable by changing the material up there. It just didn't matter. It just would have made the cost more expensive for the customer.
So the machine comes off the welder, it's welded up, it's ready to go. Then what happens to it?
Then what happens?
It gets sent down the tube.
Drops into the tube, goes to the guy on the other side to continue the operation.
Right, and at this point they're just checking to make sure this weld is acceptable and that it's concentric, I guess is the word.
Well, it's checking for straightness.
Straightness.
Most of our aluminum parts the processes are so optimized we can run those unmanned. And we run a lot of our machines, about 50 to 60% of our machines run unmanned at night. And no human being here in the shop, they just run unmanned.
But for your suppressor parts that are in canal, you've got a human being standing in front of that machine.
Yes.
As long as it's running.
Right. An in-canal in stainless steel, we have an operator on the machine all day long, because they have to check the tool wear, they have to check the parts, and they have to make offsets in order to keep the quality.
So we were just on the other side of this and we were doing our laser engraving. We dropped in on the other side of this wall, checked it for straightness. And at this point, once it's checked for straightness, it drops back through this wall.
Drops back through.
And we know it's straight.
But yeah, so it's straightened. If you pulled up the code, it would show us.
Check in the box.
Yeah.
It's straight.
Shows us, it's straightened and what he straightened it to.
Got it.
So
even the tolerance to how it,
there's a tolerance.
How straight it was,
yeah,
is
there's
recorded.
A plus or minus to everything.
Right. So the internal assembly, which is mount components, baffle stack, end cap, all that stuff, got pushed into the tube. Tube was engraved, and then it came over here, and tube is welded to the inner assembly.
Tube got engraved, got pressed onto the inner assembly, then came over here, and the tube was laser welded onto the suppressor assembly.
And so once the tube is welded on the assembly, where do we go from here?
After it cools, it gets checked for straightness, only if it needs to.
Oh, okay, so it just checked for alignment.
Usually doesn't, but we verify that it's right. Then comes over and gets wire EDM.
Each process we have a upper and lower control limit, a requirement. The drawing says the TIR can only be so much.
What is TIR?
Total indicated runout. Let's say we catch something at the very last operation, we will go back as far as we need to make it new and then bring it back forward. So if we find something, there's an anomaly that got through, and let's just say the TIR is bad, we'll scrap that whole suppressor out of the process and we'll make a new one. But we have, in my 11 years here, we've not had a situation like that.
And so Barry, explain wire EDM to me. What is this?
Okay, there's a really fine metal wire that has electricity flowing through it, and it removes the steel without putting any pressure on it.
Right.
Super accurate way of cutting material out, and we use it, so the suppressor is mounted just like it is on the weapon, and then we cut through, and that way we get a bore of the suppressor that's concentric with the mounting surfaces of the suppressor.
So to way oversimplify this process, basically you're cutting the bore of the silencer at this point.
I'm truing the bore.
Right.
So there's already a hole through it, but
the wire's got to go through something.
We're actually cutting away extra material and making sure the bore is absolutely perfect.
So the baffles and end cap and all of that stuff was intentionally machined a little undersized on diameter.
It was.
And then it's cut away to the actual final dimension of the bore. Again, perfectly straight to the mount on that specific unit.
That's correct. And if you look, like, all these EDMs are the same, but this thing's going to fill up like a fish tank. And it has to be underwater for the EDM process to work.
Oh, electric, yeah.
And so right now it's filling up.
And this liquid going in there, that's not just tap water, I'm assuming.
No.
Yeah. This is that fancy California tap water.
Yeah. It's gone through a few deionizing filters and all kinds of happy stuff.
And all that filtering is done in-house, or do you order this water and it gets
no,
shipped in the tank?
it's all being filtered in-house right behind the machines.
Very cool.
As it comes in.
Out of curiosity, is that a part of the machine, the filter system?
It is.
So it does come in piped city water. It goes through a number of different filtration systems.
It does.
And then pumped into this machine.
Yes. And then pumped back out and filtered again. Where that little cursor is going, that's where
Sure.
the wire is cutting inside of the EDM. And this is the slowest process of the operation. Therefore, we tripled it.
How long does it, so from the time that the operator comes in, he sets his little RFID tag on there, gets the suppressor mounted up on the jig or work holding device, whatever you got in there. How long does this thing take to actually run water drained part off into the next stage?
It's going to vary depending on the suppressor.
Of course, a bigger bore would take longer.
Bigger bore, a longer suppressor.
Longer suppressor, more material.
But you know,
on average, I mean, we're talking half an hour.
No, this is probably a 6-minute operation, 6 to 8, depending on model. Dennis is giving me 5, or is that 4.5?
5 to 10. 5 to 10. Got it.
And then we'll take it out. We actually even have a heat dryer. So we dry the suppressor. So basically we cook it a little bit to evaporate all the water so it doesn't move into the next station and end up leaking water into the paint booth and things.
We just came from wire EDM. What all gets wire EDM? Does that just completed baffle stacks, internal and external tube, or muzzle devices or anything else run through the wire EDM?
No, the complete suppressors run through the wire EDM. So any of our rifle suppressors would be the non-assemblable suppressors. So like a pistol suppressor doesn't get EDM.
Your sealed suppressors.
The sealed
SOCOM RCs and minis.
All the suppressors that are heading down range.
Got it.
Everything. So every non-take apart suppressor we build is wire EDM.
And so from wire EDM, we come over here, and what is this machine we're looking at?
This machine is a robotic bead blast and coating system.
And so right off the bat, my initial reaction to this is, why in the world is this a robot and not a human bead blasting it?
Let's say you had a normal shop and you got a bead blast cabinet. You got a guy with let's say he comes in, he had a great night and he's hungover and just not really thinking about work. And
I know that guy. I've been that guy.
Yeah. Anybody that's been in the Marine Corps has been that guy at one point or another.
Yeah.
So he starts bead blasting. Well, when you bead blast, it actually removes metal. If you hold a bead blaster over a piece of steel, a piece of Inconel, you can actually blast a hole in it if you leave it there long enough.
Right.
So one of the first things I did, even back when we were manually welding suppressors, it was still an automated bead blast system because I didn't want, there's no practical way to check somebody blasted a thin spot in the tube. You're not going to see it, but it's going to be there. And I don't want the guy finding out about when he's downrange in Iraq that his suppressor
has got a thin
tube.
spot in his tube.
Right now it just came out of the bead blaster. It's going over to the paint. So it's not only been bead blast, it's actually been blowing free of dust in there too. Now it comes back and the second robot takes over and starts putting a beautiful coat of Cerakote on. Like for instance with Cerakote, if you let Cerakote dry for 30 minutes or so and then spray on another coat, it'll actually crinkle off when you shoot it.
Right.
It'll look like it. I've had guys, oh hey, I repainted my suppressor. It's like, from a combat standpoint, who cares? From a cosmetic standpoint, you can't paint wet Cerakote over dry Cerakote.
Yeah.
It's not gonna last once it vibrates and heats up.
Yep.
You're gonna get like, the suppressor looks like it has a sunburn for now.
And another good reason why your rough work machining stuff, your belt sander and disc grinder and all that stuff in there, we're inside of a negative chamber room because you don't want dust coming down and landing on this.
That's exactly it.
And so a big theme here at SureFire, I know just from being a SureFire fan for years, is made in America.
Absolutely.
So talk to me a little bit about not necessarily just assembled in America or assembled in California or any of that. I'm talking to me about raw materials, even down to the screw on this suppressor.
everything's made here, sourced. Most of the materials come from the U.S. There could be something that's still DFARS compliant that came from some country that the Defense Department deemed worthy.
Right.
But it was interesting because we started doing titanium suppressors. I went to a titanium convention in Las Vegas to, hey, let me go to the SHOT Show of titanium.
Right.
And it wasn't quite the biggest SHOT Show, but walked around and the people that were selling titanium went up, hey, I'm a suppressor manufacturer, I want US titanium. And they go, wow, we sell titanium to quite a few different suppressor manufacturers, but all of them want Chinese.
Interesting.
I had that said to me 3 different times that day.
Right.
That, oh yeah, we sell stuff, but why do you want American? I look at it, if we're buying something from China, we're supporting the People's Republic of China Army.
Right.
And that's not my goal.
And so at this point, it's come off of paint, it's dried. It goes to this guy's station, and he's sitting here and doing final assembly, basically.
He's doing final assembly, but it's even down, he's putting dry lube on the lock ring.
Right.
So, the lock rings, it's fine to oil them, but you don't have to. And it just depends. I had a Marine General Bagdalini tell me once, I asked him a question, he was VP of Colt at the time, asked him a question on this rifle as far as reliability of it versus an M4 that he was showing me. He goes, you don't know the reliability of something until it's been in combat for at least 3 years.
Right.
And I really took that to heart because, when it came to the SOCOM contract, Crane came back and they said, hey, is there anything you can do to improve first round flash? Is there anything you can do to make the attachment better with gloved hands? And is there anything you can do to further increase durability? And they showed up out here 2 weeks later. We've been working nonstop.
Right.
And, we're sitting across the conference room table from like, yeah, we got it done. Let's go out to the range. And we went out to the range and, they were planning on this being a long drawn out evolution. So they went in and did basically did a recompete of our new suppressor with the suppressor that we won the contract with. And
the new suppressor being the RC, and
the
old one being the
SOCOM 556 RC, or what became that.
Right.
And basically, we got rid of first round flash. We added a blast shield that shielded the tube and no more than doubled the amount of rounds you could put through if you were trying to hammer a suppressor, and did that without increasing weight. And we changed, we'd actually had the lock ring already, but it hadn't been in combat for 3 years. So we ended up adding the lock ring, and we also added the index notch on the bottom, that little tab on the bottom of the flash hider. And that was part of that too, because they wanted one way for the suppressor to go on, because they chose the open tine flash hider that we had. Yep. And there were a bunch of different, 8 different positions that thing could fit on. Yep. That it was.
But to a good point, and pardon me for interrupting you, but that's a great point where the new RC lock ring collar still works on the FA muzzle devices.
It does.
It just doesn't have that indexing notch, so you can end up mounting it.
You can mount it either way. If, from a functional standpoint, if I try to mount the suppressor same orientation every time. Yeah. But the suppressor, you lock it on you take a SOCOM suppressor, put on a non-earlier, like an FH556-212 flash hider. Yep. It'll lock onto it, same bearing surfaces, same attachment, just different indexing. Right. And if you put it on with the serial number at 12 o'clock, tighten it up, and you can shoot it for a day, you can shoot it for a month, it's still going to have the serial number at 12 o'clock. It's not going to walk around in circles on you. Right. But,
it's the taking it off and putting it back on.
Yeah, and I come from, in shooting, I taught early on, hey, do the same thing the same way every time, and you're probably going to get the same result. So, don't change the way you're standing, gripping the pistol, or anything like that. And so with this, having the suppressor go on exactly the same way every time, just leads to more consistent, better results.
So from this kind of final assembly stage here, as everything starts to come together, where are we headed to next?
This is the first batch operation that gets done. So the suppressors are coming in here. When this tub's full, the tubs will go out to the range and get test fired. Every suppressor is test fired for accuracy and point of impact,
and recorded.
Right. So we fire through an acoustic target, so we know which was the first round, second round, third round. We used to fire 5 rounds through every suppressor. Then Dennis did some statistical analysis and came back to me. He goes, every suppressor that we've ever had that didn't pass test fire failed within the first 2 rounds. Wasn't the first 3.
That Dennis is a smart guy.
Dennis is a very smart guy.
Yeah.
So we went back in. It was like looking at we get 11 to 14,000 rounds out of a test fire barrel because we're shooting 3 rounds at a time. We're cooling it with cold air in between suppressors. So not bad, but if you're test firing 150 suppressors a day, you go through barrels quite a bit.
Right.
And we're right now starting to use one of the bench rest rifle builders to get some pre-chambered barrels set up for actions, but we've been doing it in our own shop, so that takes a guy off building whatever my next creative prototype is, and now he's over here like building a rifle and being a gunsmith.
Right.
So for those reasons, we're switching over, but going to 3 rounds of suppressor instead of 5 means we get a lot more suppressors tested per barrel.
Awesome.
We'll take a suppressor and then we will slice a thin slice all the way through on all the welds, and then we have some big pucks out of them. She'll come in and lap them, and then we are looking at all of the welds for each one of the baffles and the spacers.
And so when you're looking at the weld, are you looking at thickness of the weld, or?
Yes, we're actually looking at the thickness of the weld, the penetration of the weld, the porosity of the weld, the quality of the weld.
The whole thing, through and through.
The whole thing, through and through. So every weld is checked. Our inspector gives us a report and says we're okay or stop, we have a problem, and then we can go out to the line, stop right then and there, see where maybe we have to make an adjustment or something on the...
So from a process standpoint, if you've got, let's say, 5.56 RC2s that are out there getting welded, and you're doing, I don't know, 200 of them, let's say, in a day. I don't even know if that's a reasonable number, but I made that up.
Yeah.
If you're doing 200 of them in a day, at some point during that day, one of those gets pulled off the line and gets checked as it's happening.
When the very first suppressor that ever got welded is actually pulled off.
The guinea pig.
Yeah. It's pulled off, it's sacrificed, it's cut.
Got it.
And then what you're seeing here are examples of all the different weld joints that are looked at inside the suppressor.
Right.
And this is those magnified, but then once that is set up and good to go, that stays good for that production run.
So that lot of production, and let's say you retooled after that and you're set up for 7.62 RC2s, the same process happens
Same process again.
And when you tool back to 5.56s, you're going through the same process again. That's incredible.
We do a first article
anytime that machine changes.
Right.
Awesome.
Yeah, but it's not, I mean, we could run the same thing for a week. We aren't going to go back and, we haven't found a need to.
Right.
We haven't found a quality issue where, okay, hey, every 200 suppressors we need to check something.
Right.
It's just when we put anything new on the line, we got to go through and certify it.
It's a great example of buying the right tool for the right job.
Yes.
You can check it once and it's good for the line.
Right. Yes.
Awesome. All right, Barry, so we've come out of the production line there at the SureFire facility and we're out here at the range now. What are we doing next?
What we're doing next is a suppressor accuracy point of impact test. So every one of SureFire's rifle suppressors is fired for a 3-round group.
And I just want to stress that you said every one of, correct? It's not like a sampling of, every single serial number.
Every single one. And reason for that is we have a large portion of military customers. Some of them are in the States, some are overseas, and some are deployed. You know, as far as like U.S. and NATO-friendly countries. And when a suppressor gets issued to somebody that's already downrange, it needs to work. So this is one of the real final QC checks. And we don't find many suppressors that have an issue, but we want to find it here if any of them do. And it's just that peace of mind that we know every suppressor that went out shot well before it left the factory.
Got it. So we saw the guy doing final assembly, loading up these bins there at the SureFire facility. And we're going to take these and we're going to set them up here. So will you walk me through how this all works?
If I go back to the beginning, I used to test fire all the suppressors on real sniper rifles. And then it came to, okay, we're getting bigger and we're getting bigger. Okay, I can't be on the range 5 days a week. So needed to find a way to shoot this. I tried hiring people before I found these fine gentlemen, long before them, because they're obviously excellent shooters. So we ended up, there's a sport of unlimited class bench rest shooting. I'm not a bench rest shooter, never shot a unlimited class bench rest match, but called up guys that build the unlimited class guns. And some of the differences, unlimited class bench rest, they can't bolt to the bench. We aren't shooting a match, I can bolt it to the bench.
Right.
So this is basically a lathe carriage, and it self-points the gun. And what we'll do is come in, we shoot unsuppressed group of record, tell the target that is the center of the group, and that's over here on the laptop. And then we'll mount the suppressor up and go through and shoot 3 rounds. We shoot Black Hills 77 OTM. Most 77 OTM is the same as Mark II 62, but not necessarily all of it.
Yep.
All of what we buy is. We'll go through, shoot a 3-round group. They're watching the impact. We know the first, second, and third shot, and we've got that permanently saved. So if there's ever a question on that suppressor, we can pull up that serial number. I know how it shot, what the point of impact was, what the accuracy was, and that's all done right here. If you see the covers and the different fans sucking, we're just trying to keep anybody from sucking in any undue lead.
Right.
So we try to take lead abatement serious. You know, we got the de-lead hand soap and things to try to keep anybody from getting exposed. So we keep all these guys healthy.
And what you guys can't see on camera is there is a scoop, I'm going to call it, right there, that is an air handler that is sucking air right off of the muzzle into that gun.
That's correct.
Right. And so talk to me a little bit about the setup here. There is a 5.56 bolt action with a big old barrel on there that's got a SureFire muzzle brake mounted on the end. Does that ever switch out? Obviously for 5.56 we're shooting 5.56, but if we're shooting SOCOM 7.62 today, is there a different rig?
If it's SOCOM 7.62, it's a 7.62 rig. Predominantly we're shooting bad actions. We have a few smattering, and what I did when
Bad the company, not a bad action.
Yes,
Got
BAT.
Yeah.
They make really good actions, and when I started this, I didn't know who had the best action or not, so I bought like one of every action I could find. Yeah, I went to the bench rest forums and magazines, and it was like, okay, let me get one of each, and we settled in. We still have a smattering of different brands, but for the most part, we use the BAT bad actions. When they come out to shoot 5.56, they'll always have a backup barreled action with them, because somewhere between, what are you getting, like 11 to 14,000 rounds before the barrels are shot out?
Somewhere around there, yeah.
So, and that's another reason why we have a single shot, is I wanted to limit the amount, how fast they could put rounds down range so the barrels last a little longer. Every so many suppressors, put a cold air gun in, we cool the barrel back down, so we increase barrel life.
Just about to ask about that. You've got some fans set up on the barrel, blowing air out that way and cooling the barrel somewhat, but you've also got a fancy pants little air gun sitting over there that I'm assuming is what goes into the actual action here after a certain number of rounds and cools the barrel back down.
Yes.
Excellent.
And it's really all about barrel life.
Awesome. And let's kind of step back, get out of these guys' hair, and let them shoot a couple of cans and see what that's all about.
Let's do it.
Pass 28071. Send it.
Calling off the serial number as he puts it on the gun, and then you got your guy over here manning the computer, confirming that those are meeting whatever that tolerance is, that 1 inch.
That is
POI,
correct.
POI.
Pass.
And that target and all of the data for that specific serial number is saved, as we were talking about earlier.
It
and
is.
Part
Along
of
with
that suppressor's
along
record.
with all the production information on who did every operation.
072.
Got it.
072. Pass.
And how long do you let that run normally?
Normally to it's full to the stud. We still have to clean those off, put them back on. We want to prolong the life of the barrel, like Barry said, as long as possible.
Right.
So we don't want to run it when it's too hot. There's no rush. As long as we get preserve the life of the barrel, get some good shots on range, preserve the suppressor.
So suppressors at this point sit over here, they cool down. Obviously they just had 3 rounds through them. They're not too hot, but they're a little too hot to put back in the bin.
Yeah, then they'll put the plastic sleeves back over them to keep them from getting nicked or scratched when they're in the bin.
And then they go back in the bin and back to SureFire
Back
facility.
to the receiving side, so then they go back to the packaging side at SureFire.
And they get packaged up and
Packaged up, sealed, and that's the last time a human being touches them until
Awesome.
you and your customers open them up.
Hail.
can you walk me through a little bit what we're looking at here on this screen? What is all of this?
All right, so what we have here is our shot group for our suppressors. So the best way to check that is you're going to see your group size and you're going to see your point of impact shift distance. Now, your point of, say for instance on this suppressor, we have 1.1 group size, which is over our tolerances. Okay, so we'll take it, the suppressor off, relatch it, and shoot the suppressor again.
Got it.
For a second shot. And as so right here, we're going to reshoot one. 076, reshoot one, set it.
Pass.
Okay, now the reason we're doing I would look at that, the reason we should reshot it is it's always possible there's a bullet with bad concentricity
Sure, of
or
course.
something like that. So
That's what I always tell my wife when I miss the target. It was
Yeah.
the bullet's fault. Yeah.
absolutely,
Yeah.
that's process, but if it failed here, we don't keep trying until it passes. We're done, we take it back, we figure out what happened.
Got it.
The ultimate proof that the process is on the floor are in control is the end result. So on this particular chart, we've got over 90,000 pieces of rounds going through. And then this particular one is all of the suppressors. So I want to look at the processes by suppressor, but then again, I want collectively the whole process, make sure there's no variable in there. So this particular group, this is all the suppressors combined. We have a 0.57 group size, okay? And that's 90,000 rounds at a 0.5. That's phenomenal. 0.5 of an inch, yeah. And then the same thing with on the POI. Here again, it's the same rounds going through. We've got 90 pieces and we're at a 0.4. So your point of impact shift is 0.4 of an inch collectively on all of the suppressors. And then we break it down by each model.
And so that 90,000 rounds that we're looking at on that top left graph there, that's across how many products? How many individual serialized silencers?
About 30,000. Figure 3 rounds per, it's about 30,000. about,
That's how many years worth of product?
lately it's about 2.5 years.
So we're down at the business end of the testing range here. Walk me through what exactly I'm looking at here.
Okay, well, being we're shooting an acoustic target, you know, and with a rail gun, we don't actually need an aiming spot. So with the rail gun, you know, they'll essentially bore sight it, and then they'll fire a unsuppressed group out of it. They'll hit, you know, to have that group be the group of record.
Right.
And then the suppressors are all based point of impact off that group.
That group of record.
And occasionally we put a target frame up, and that's where you get some of these other shots that are here depending on what we're testing. Because we've done some rifle stuff where we've been out here and went through about 130,000 rounds over a few weeks. And with that, you go back in and, you know, so you put the human factor to it, you get some groups in different spots.
Sure.
And then what you see behind there is a bullet deflector. So we started shooting these, and all of a sudden we looked down, and there was a hole in the berm about this big. And I took a shovel handle and pushed it all the way through. It was in the winter, so the soil was a little more packed, and the shovel handle didn't bottom out. And it was like, okay, eventually we're coming out the other side of the berm.
Right.
So I took a piece of A500 and put it at, you know, I don't know, it's probably at a 25-degree angle or so. And the bullets hit it, frag out, and they don't dig a hole through the berm anymore.
Makes complete sense. And this target set up here, you got sensors set up in...
Yeah, there's actually 8 sensors on this that triangulate the location of the bullet as it goes through.
Awesome. And that reports back to that laptop?
That reports back to that laptop via Wi-Fi.
Cool.
Or actually Bluetooth, I believe is what it is, but it's electronic. At one point we had a wired target that yeah, we had running, but it didn't do all the things that our new target does.
Let's say somebody calls up and I get the email, and then I say what's going on. First thing I'll do is I'll pull the serial number, I'll go into our database, and I'll pull all the history, the job, the method of manufacturing, all of the QA buy-offs and all of the measurements and all the tools we use. I'll pull that up and say, hey, was this on the high side of the tolerance, or, you know, was there anything in the manufacturing that would lend itself to this? If not, then we'll pull the test fire charts and correlate it, you know, there and say what happened at test fire. You know, this maybe this one was on the high side of the TIR at the front bore, and we came into test fire. Let's just say if it was 7 or 8, well, it met the requirement, but it was a little bit on the high side, so maybe there's something here. And then we'll inspect it, cut the tube off, put a new inner on it with the same new information, take it out to test fire, see that it, you know, that we've remedied the issue.
So right now, like if you get at the front, you know, I'm right at 8 inches the center of the mic.
Got it.
And then, you know, it's a eye measurement as far as keeping it squared.
Yep.
And we came up with this position. It was long before we had a setup like this. With this, we were trying to get at the ear, but the microphone needs to be vertical. And with the microphone and the preamp and everything, this was as close as we could get without the shooter's shoulder knocking the tripod over and screwing up our measurement.
Yep.
Most things will say measure over green grass. I actually brought a truckload of sod out here and set up over different surfaces and then set up over sod, and we got the exact same measurements because we're measuring peak. So with this, we went in when we did it, we had a sound engineer out, and we started you know, doing tests to make sure we weren't catching things off the mic stands and stuff, and we were solid. And then this, depending on what you're firing, you know, a lot of times we found we're too short.
Yep.
So that's where, you know, the target actuator from IPSC and 3-gun practice also doubles as a
good foot
good foot stand.
Yeah.
You know, sound level, we're always trying to make the suppressor as quiet as possible, but a suppressor is a balance with what you're putting it on, what you're doing with it. I can get more sound out of, like, say, let's say a SOCOM 556 RC2. I've made significantly more quiet 556 suppressors, but they had too much back pressure for use on anything but a bolt gun. And I used to be able to say, you know, hey, I got 30% less back pressure than anybody else out there, because we did. Now there's some suppressors that have less back pressure than ours, but they got more sound and flash. So it's that balance of, you know, what's important. And most of my customers are telling me that flash is a really big deal to them. And I've tested some of these low back pressure suppressors that were over 150 dB at my ear. That's getting into the 9 mil category. At some point, if I have to have hearing protection on anyway, I might as well just put my hearing protection on and shoot a war comp. When it comes to sound, although it's the last thing on my checklist of what a suppressor needs to do, it's still a super critical piece.
Right.
And so, but the way I look at it, if the suppressor, if you don't have point of impact repeatability, if you don't have minimal point of impact shift, if you don't have, you know, flash reduction, depending on who's buying the suppressor,
Right.
you know, and if you have too much back pressure that the guy can't, you know, reliably shoot the gun because his eyes are tearing up. So it's a combination of all these things.
And if you don't hit all of those things by the time you get to sound, that's a problem.
Yes.
Right.
And so that's where, you know, it's really, you know, a lot of our stuff is customer specific, but that's where, you know, we have muzzle brakes, flash hiders, war comps, and a lot of different options, closed tine versus open tine. The closed tine flash hiders are, it's actually only a few % more effective, but it's visibly seeable with the human eye. And the open tine flash hider, we've never tested anything that outperforms our SF3P.
Right on.
That's like the pinnacle, and we were happy with that. We tried to maximize the mass on the tines and strength, because I was just thinking if some guy gets shot at running across the street taking a nosedive into his muzzle,
Right.
I didn't want the tines getting bent over the bullet path. You know, little stuff that you don't necessarily think about, but
Oh no, as soon as you said that, I thought about a couple of times where I've taken a nosedive and the muzzle's gone straight into the dirt. Okay, so we've done our test fire, we've done our sound testing, which obviously doesn't happen on every can, but I wanted to take some time. Kind of the reoccurring theme throughout the SureFire visit here has been the attention to detail and the accuracy, the repeatability, the efficiency of the process, but the worst can happen. So I wanted to take some time with you out here and kind of walk through when you guys see an issue with a can and it comes back, what does that look like? How do you handle it? What's the process for handling it? And kind of the ways to avoid it. So if you would, kick me off, number one, by introducing yourself.
Yeah, absolutely. My name is Paul Glass. I work in the suppressor division here at SureFire as a project manager. I also run RMAs, the RMA department, which is Return Merchandise Authorization. So I deal with any product that may have a mishap in the field. The customers can return it into SureFire. We're going to QC it, determine the issue that they had, and we're going to go ahead and repair or replace if needed.
Very few SureFire cans come back to you guys on an RMA, but the ones that do, what are the common causes you see for that kind of thing?
Sure, yeah, you're right. It is a low percentage. What we commonly see are a few different things. We'll see a lot of improper attachment and a lot of bullet strikes due to alignment issues. So the issue with alignment, it could be a few different things. We have you know, an adapter, a flash hider, muzzle brake, whatever you're mounting your can on, and then, you know, that attaches to a barrel, which is a variable. We have the suppressor that's a variable. So any of these items can be the problem. We have a shim kit and a spacer that is used to bring all that together. So what we like to do is, just a quick reference point is a bore rod. So SureFire sells the bore rod line, a suppressor alignment rod, if you will. And so what we want to do is just install the rod into the weapon system that is cleared and on safe, of course. And what we want to do is let that rod highlight where the bullet is going to be exiting the suppressor. And what we want to see is that rod in the middle third, essentially, of the bore. You know, it's not always going to be perfect, but if we're in the middle third, that we've had no issues with that sort of thing. When you start drifting over to any other side, you can have accuracy issues. If you get too far, you can have bullet strikes. Bullet strikes with our suppressors are not in-field serviceable because our suppressors are fully welded.
Sure.
So when that does happen, those suppressors need to come in on an RMA. We basically have to rework everything from scratch. And then what I like to do is inform the customers, if they don't already know about bore rods, is to make sure that they're using something in just to double check the alignment of everything they have. There's a lot of variables. We just want to start figuring out what's causing the issue and then do our best to remedy that for the customer.
Right, you don't want to send out a fixed silencer back to a customer who has a misaligned something
Correct.
in their system
Yeah,
and have it happen again.
It's a vicious cycle. If we continue that, they're upset, it doesn't help us. We want to just help them get past whatever's causing the issue. So we do our best to talk with the customers directly, inform them of suppressor alignment rods and a few other things they could check, just to make sure that when we do repair it and send it back to them, that they have a better experience with it.
Right, and to back up on you a little bit here, the bore alignment rod, you're sticking it in the business end of the firearm with the suppressor completely mounted, locked on there as if it would be in a firing configuration.
That's correct.
And you're basically looking down the business end of this, obviously with the gun cleared, bolt back, on safe, all those things, dummy check. You're looking down that bore rod to make sure you have quote-unquote daylight around the outside of it. And it may not be perfectly centered in there, and that's within tolerance acceptable, but you definitely don't want that bore rod hitting the end cap or one of the baffles.
That's correct. That's correct. And a nice way to check, bore rods, if they ever are to get bent, they'll be telling you false information essentially.
Right.
A nice way to check that is if you see that, let's say for example, your bore rod is favoring the 6 o'clock position and you're wondering if maybe the rod itself is bent, I like to 180 that rod, take the suppressor off, 180 that rod.
You just covered my next topic.
And if it goes to the 12 o'clock, then we have a rod issue. If it
Right.
stays at the 6 o'clock, you have an issue with the attachment somewhere.
The common fix you see for that on the internet, which I definitely want to stress to all of you, is some guy on a forum somewhere tells you take the rod out and roll it on a table.
Sure.
To make sure that it's flat. But I promise you, your kitchen table
Is
is not flat.
Right.
It is much less flat than your bore rod is.
Absolutely.
So you roll it on the table and it wobbles, but it's because your table's out of flat. If you've got some crazy, you're a machinist, you got a granite reference surface or something like that,
Granite
that's
block.
a different story.
Certainly.
But the other quick way of doing that, which your system is the one I prefer, put it in there, rotate the rod, make sure your rod didn't change that orientation.
Absolutely. For the average consumer, that seems to be the easiest method to detect if you have an issue with the alignment rod or not.
The other one is not quite foolproof, but definitely better than your kitchen table, which is just a piece of plate glass, which is typically much flatter.
Absolutely.
And just rolling it across there and make sure the rod rolls evenly. And doesn't
Absolutely.
wobble on you.
Yeah.
Cool.
We do get quite a few RMAs just because of the volume of product we have on the marketplace.
Sure, of course.
So even though it's less than 1% of our product, it's still a little bit of product. It does trickle in. And one of the oddest ones we had was a suppressor that had dislodged from the weapon system mounted in a helicopter. And it took a pretty bad spill, and I think it hit a lot of stuff on the way down. It was pretty marred up.
Hit every branch on the way down.
Yeah, it was, and when that came in, it was definitely an iconic moment. It was like, I've never seen anything quite like this. Surprisingly, the suppressor still shot. It just, was pretty badly beat up on the outside. But as far as, alignment and concentricity, these are really, really rugged suppressors. And it takes quite a bit to actually, bend them or damage them to the point of non-use.
Right.
And another nice thing we have is the fail-safe baffles. So even if something was to be off and you were to get a baffle strike, that's quite all right. That bullet is just going to, basically take out some baffles and continue just straight down range on its original trajectory and not change directions on you and come out the side.
Right.
That's part of the patented, fail-safe baffle system that we use in the SureFire SOCOM suppressors.
Awesome. And how long have you been at SureFire?
I have been with SureFire 11 years now.
And in your 11 years at SureFire, surely there's at least one, if not multiple, kind of a memory you think back on, or a project you worked on, or a product you worked on, or something that happened at SureFire that sticks out in your mind as kind of a proud moment or something you really stood behind or something like that.
Certainly. Being that I had been there so long, I was around when we submitted for the original SOCOM contract. And that was quite a bit of work, actually. It required a lot of different samples, a lot of testing, a lot of late nights, a lot of weekends. And you basically, we submit it all and then basically wait for an approval or a denial, of the contract award. And I want to say it was about a year later that we were able to win that contract. Even though this was back in 2011, it's still a very proud moment for us and for SureFire as well.
Sure.
And it was nice to be able to have worked on such a significant project for the company.
Absolutely.
and for the military for that point too. We're very proud to serve the military with the best products that we can build. That's very, very important to us at SureFire.
That's another one of those reoccurring themes I've heard from almost everybody today. Yeah.
So when a baffle strike RMA comes in, the first thing we do is put every suppressor, every product that comes in, whether it be a flash hider, suppressor, anything that comes in on an RMA, it all goes through the QC department. And we basically just want a legend of what's happening with this product. You know, what's out of spec, what's not out of spec, and that will help us determine what we need to do. So everything goes through QC, we get a report. From that report, we'll look at the product, we'll look at the report, and we'll determine what we need to do. The suppressors, the suppressor RMAs that require the most work are baffle strikes, again, because they're fully welded. They require basically a ground up rebuild.
Right.
And so what we do on those is we send them over to the machine shop. They actually remove the tube, which is the serialized portion, that is the weapon. The rest of it gets scrapped. We build a whole new inner assembly as we were building brand new production, slide the original tube over that new inner assembly and finish it up as an existing product with basically everything's brand new other than the tube.
Right.
At that point, it'll go through paint, it'll go through test fire just as anything else would. And once we've verified that everything is properly reworked, it gets final inspection, packaged, and shipped back to the customer.
Awesome.
So the suppressors will come in from test fire. They'll come into here. The guy will take them in, pull them out of the sock. They'll wipe them down. They'll do a physical ID and damage on it, make sure that there's nothing wrong with it. We'll do a quality check with a go, no go to make sure the timing is good with it. From there, it'll come in here. They'll wipe it down again, and then we'll box it up and put the pamphlets in it. We'll put the brush, put it in the pouch, and then it goes with seals. And then from the seals, it goes into the vault. So if these seals are broken, we know somebody's tampered with the box.
So at what point, each box is serialized, obviously, to match the tube that's inside of it.
Correct.
At what point is that serialized sticker printed off?
This sticker actually comes off of the RFID tag that you...
Ah, so it's actually, it goes with the silencer the whole way through.
Yeah, see this?
That sticker's been with it since we started.
From inception to now.
Clever. So if at some point during the process they're looking at it and they see something out of whack, it made it this far and there's a chip in the paint or something like that.
We'll take it back, strip it, repaint it, take it back out and retest fire it, and bring it. So we'll take it far back on the process as we have
as was broken.
To where it's broken, and then back forward.
And then all the way through, you're not skipping a step back after that.
No skipping that.
I'm in SureFire for 22 years, and I have seen the change of the product from simpler part to more complex parts. The products have changed a lot, and what I really like is the complexity. I like complex parts. I don't like something simple. I like more the complex application than the simpler application.
If you had kind of one motto for SureFire and your role here and kind of your motivation for this, what would it be?
Sense of urgency and a bias for action.
Right, and it's pointed up to a banner on the
Yeah. No, that's everybody here. If we have something we got to get done, there's a deadline. Everybody knows how urgent it is, and everybody takes and does what they've got to do to get it done. So it may not be my job to do paint, but I'll go paint to get it done. But it's got to be done within the quality requirements that is needed. So, but we just jump in and get the job done. There's days you got deadlines, you're like, oh, we're gonna make that happen.
I'd been originally with SureFire Institute, and I got into suppressors because in the mid-90s everything was going from MP5 to M4s or short barrel versions of the M4s, you know, the 10.3s, 10.5s, and it was getting really loud in the house. So I started calling up suppressor manufacturers and met this one guy, and he had all kinds of math formulas and everything, and kind of got along with him. It's like, man, this is a smart dude. And ended up doing R&D for him. I wouldn't really say I worked for him because I didn't get paid, but I was more passion driven, just off active duty in the Marine Corps, still, on the reserve side. And I was working at SureFire, traveling around, teaching CQB. Well, I ended up starting to, demo suppressors for the guy, and then ended up setting up a shop and, building prototypes. After 9/11, I decided I was going to go back in the military. Then ended up finally I got with 20th Group, and I was able to get them to send me to SFAS. And right before I left, the guy comes to John Matthews and says, "Hey, I want you to buy me out." And he'd been promising me the company the whole time, but that wasn't really, I was fine with it. So I'm like, great. Yeah, there's suppressor solicitation coming up for the military to replace the suppressors at SOCOM. I'm going to go back in, I'll have a good suppressor to carry, and SureFire will be building it. So I leave, go off at SFAS. Well, I come back, and the guy had gone back to John Matthews after I left, said, "Hey, I want more money." And John said, "Well, I gave you what you asked for." And I was, well, I want more. And he goes, "You know what? I want you to be happy, so I'll give you the addition." And 3 days later, he calls up, "Hey, I want even more." And John goes, "Hey, I made you a fair deal twice. I gave you what you asked for. We're not doing this again." I get back, and this whole deal's falling apart. Now I was faced with a situation where I was going to go back in the military, and I was going to be carrying a crap suppressor. So I started thinking about it. I'd come up with a lot of different designs over the years that had been given the thumbs down. And so I went to John Matthews, and I said, "Hey, we got 90 days till there's a submittal for a new suppressor for SOCOM." I said, "I can move all the machines out of my garage into SureFire. I'll design you a suppressor in 90 days. And then I'm going, a few months after that, I'm going to go try to pick up a slot for Q course, and you can let the people that build stuff build it." John said, "Okay." So we spent, pretty much, I was sleeping at a hotel because I was living in San Diego at the time. So I'd go sleep for 4 hours and come back and, work for another 20, 7 days a week for 3 months. Had a couple other guys helping me, and we came up with the first SureFire suppressor. And then submitted it, took a few days off, watched it actually get loaded on the truck, get shipped. Well, we get notified 2 weeks later that, "Hey, your suppressors your box arrived 5 minutes late. We aren't going to open it or test them." And we thought about protesting it, but we didn't want to keep anybody from getting a better suppressor. So we said, "You know what, we're just going to let it go." At this point, I had employees here, I had manufacturing stuff I'd set up, but I knew if I left, it was going to fall apart. So, I asked the reserve unit that I was with, that was my son, I said, "Hey, can you give me another 6 months?" And they said, "No problem." So went in, kept trying to get everything, get all the infrastructure set up, because what I discovered was SureFire was really good at building flashlights. And when you look at building suppressors, now you're stamping parts, machining parts, welding parts. And although they were really good at the machining part, they had no knowledge of the stamping part or the welding part. And so I was essentially setting everything up from scratch. At a certain point, I looked at it and I was like, man, I'm taking somebody else's seat, that could go. And although, I don't think I would have regretted it at all if I would have gone that direction. It definitely was one of those pivotal points in life where I said, you know what, I'm going to finish this thing. I'm going to send, basically design the very best suppressor and get it into the military. And in 2011, 2012, we won the SOCOM contract, and we're now on every M4, every M16 in SOCOM. And we're on the Mark 13 SOCOM sniper rifle. We're on the Marine Corps M40A5, M40A6s. And around the world, we're, it's a pretty good who's who of NATO countries where their top special forces assets have been running our suppressors now for a number of years. Either way, I don't think I would have regretted the decision, but at the same time, never saw myself as a guy that manufactured stuff. But, at this point, got great infrastructure and a great team, and we're still building great suppressors for the military and for silencer shop customers around the country.
All right, guys, thanks for watching this very unique behind-the-scenes look at what goes into a SureFire silencer. And right off the bat, I want to give a huge shout out and a big thank you to all the fine folks of SureFire for letting us come out and do this never before seen kind of stuff, what goes into their products. I hope you guys understand how much an absolute treat it is to be able to see this from a manufacturer the caliber of SureFire and the amount of attention and detail they put into their QC process and every single one of their products that comes off of this line. I hope this kind of explains to you how SureFire got their name and why they are who they are. So for more information on SureFire products, don't forget to subscribe to this page and check us out on Facebook or Instagram. Thanks, guys.